Right here is fine. I'm just going to stand with you. So welcome, everyone. Now is the time for us to start. So my name is Ben Marwick. I'm a professor in the anthropology department and also the chair of the eScience Reproducible Research and Open Science Special Interest Group. And so our speaker today is a guest of our special interest group, second one for the quarter by our fortunate coincidence. And I will pass around a sign-up sheet. So this will allow us, if you will just put your name and maybe your department on here. I'll send one here and one this way. This will ensure that we can persuade other people that these events are worth putting on and it's worth to bring distinguished visitors to sort of share their expertise with us. So please add some details to that. So now I'll just give a couple of introductory remarks to our speaker and then let her take over. So Julia is marine data scientist and a Mozilla Fellow at the National Center for Ecological Analysis and Synthesis. She got her PhD from Stanford in 2012, studying the Humboldt squid and climate change, and has done a lot of work and scholarly publication on those, and also some public outreach, including a children's education program and a TV show. And a lot of this work has been featured in popular outlets such as the BBC and National Geographic and Nature News. So she's currently working on, and what she's going to speak to us about is increasing the value and the practice of open environmental science. And she is doing this in two closely related projects. One is the Ocean Health Index, and the second one is Openscapes. So the Ocean Health Index, where Julia is the science program lead, is an international project to measure how healthy our oceans are and help inform policy decisions on ocean management. So this is a very classic big team science project, which her and her colleagues published a very inspiring paper in Nature, Ecology and Evolution in 2017. It's called Our Path to Better Science in Less Time Using Open Data Science Tools, and it's a very nice kind of template. If you happen to be working in a big team science context, this will help you chart a path toward improving reproducibility and making collaboration more efficient at an international scale. So Openscapes is the second major thing that Julia is active on at the moment, part of her work as a Mozilla Fellow. This is also operated by the National Center for Ecological Analysis and Synthesis. And the vision of Openscapes, which we will hear about in detail, is about for a scientific culture that is more efficient and collaborative and then can uncover environmental solutions faster. So the aim of Openscapes is to grow communities of practice around environmental open data science and create a positive open culture in science as well. And there was a very nice overview of their approach published in the end of October, just a few weeks ago in Nature Careers column called Supercharge Your Research, a 10-week plan for open data science, which I highly recommend. And in there you'll see many tips on transforming your group, or your research group, with open data science sort of tools and principles. So please welcome Julia. Thank you.
Hi everybody. Can everybody hear me? Is this no? Is this on? Hello? It's not on. Okay. It's supposed to, it looks like it's on for the recording. Do I have to speak into the podium? How about now? No? Okay.
That's just recording,
Okay.
but
Okay. Hi, everybody. Can you hear me now? Great. Thanks. I'm so excited to be here, and thanks, Ben, for that introduction and for eScience for inviting me. I've been, as Ben said, I'm a marine ecologist who had no formal training in data science or open science, but it has inspired me and empowered me in really exciting ways, and I just love talking about it. And so this opportunity to share this with you is really exciting for me. So thank you. I'm really good. So let me also just say that I have links and other things in these slides, and they're all available from openscapes.org/media or through my GitHub page as well. And I'll share that link again later on, just so you know. But so this is the way I've been thinking about open science recently, which is that open data science and tools and practices, along with teamwork and collaboration, are part of this, this really powerful feedback loop where learning similar tools and practices really enable you to collaborate more efficiently with other people and become a team with people beyond your own domain. And similarly, if you have a team mindset and work closely with people, you might be better suited to engage with new tools and practices. And so this is a really positive feedback loop that lets you innovate across disciplines and within your own disciplines. And it, I'm still trying to think about how to describe this. Like maybe it becomes more of a spiral or a web because it kind of feeds off itself, and you're able to really innovate really powerfully. But I'm a marine scientist, and in environmental science more broadly, we are never taught any kind of rarely have formal education in open practices, in data science, and we rarely work in teams. There's a very individual mindset, especially when it comes around data, that data, like struggling with data is part of the process. So even though this feedback loop I think is really powerful, I think that we find a lot of scientists outside of this loop. And so my talk today is going to be about Openscapes, which is a mentorship program for research teams to help build mindsets and habits around open data science and grow the community of practice more broadly. And this is this project that Ben mentioned that I developed in the past year when I was a fellow with the Mozilla Foundation. And it's been incubated, or it's housed at the National Center for Ecological Analysis and Synthesis at the University of California, Santa Barbara, where I'm based. And this is the team that was part of the first cohort of Openscapes. It's a remote program, and it was really exciting to engage with all these folks. And I'll talk more about that later. But the Openscapes mentorship program really builds on the previous 6 years of work I've done at NCEAS, which is with the Ocean Health Index, which is a scientific method, tool, and community for channeling the best available data and scientific information into marine policy. So we model things that people care about and that they manage in a policy way, from tourism and clean water and biodiversity. And this is work that we first published in 2012 and that we've repeated annually ever since with an evolving team of folks. So in this picture, this includes 3 of our graduate student fellows that join us part-time for part of the year to work on our team. And open data science has enabled us to reproduce and repeat our work every year while having a sort of a new stream of people onboarding and offboarding from our team. And it's also enabled us to help enable other groups to use our scientific framework and our code and tools to assess how healthy oceans are in other geographies. So I've worked with groups in Ecuador and in the Baltic Sea, and we're working on one in the Northeast in the US as well. So there's many examples of that as well. And let's see, but so the thing I want to talk about today is just how we, as ecologists and environmental sciences more broadly, we kind of have to learn these tools along the way. And I like to talk about this in terms of analogies with Star Wars, so bear with me. But so this is Luke Skywalker after he crashed his plane into the swamps of Dagobah, and he's sitting here staring at a challenge that he can't solve with the skill sets that he has. And it's really demoralizing and lonely to be in this position. And for a scientist who comes to their research without skills with data, this can feel like not being able to open your data because Excel is the only tool you know and your data are too big. This can feel like writing code that you're embarrassed to share because you're nervous about whether all of your code is appropriate, let's say. It could also be trying to collaborate with other people and not being able to run their code. So there's a lot of different ways, both as individuals and as teams, that you can really feel demoralized and lonely. And if you think about what might have happened if Luke had tried to solve this challenge with whatever tools he had, with whatever rope or pulleys he had, you can imagine that it wouldn't have been reproducible, he wouldn't have been very proud of it, and it wouldn't have gotten him to where he needed to be on time. But luckily for Luke, Yoda comes along. And Yoda has a skill set that can solve Luke's challenge in a way that Luke never imagined was possible. So Yoda uses the Force, and Luke can see what's possible, he can learn from Yoda, and he can not only tackle this challenge ahead of him and get his plane out of the swamp, but it also is going to change and broaden his entire mindset of what's possible in the types of challenges he takes on moving forward. So in an environmental science and data science context, this can be being able to collaborate with code through GitHub. This can be having a Zoom call with somebody remote and being able to collaborate with them. Like this can be a whole mindset and tool set that can really reduce a lot of the collaborative challenges that we see in science around data. But something that's really important is that Luke didn't go on to defeat the Empire all by himself. He had a whole team of folks that were contributing to his success. And what's important too is that this team was really diverse and not everybody had the same skill set. So this is also really important in a science context. I think that not everyone needs to be a Jedi when it comes to coding, because that's a really important skill set, but there's contributing skill sets, and the way C-3PO might approach a challenge is different from the way R2 might, and both of those contributions are really important. So in a science context too, this is really important. The role that a PI can play is different maybe from an analyst or an incoming student and a project manager and a communications team. And so there's a lot of different ways that you can contribute around data science. Like R and data science feels like the Force to me in terms of the power it gives you and the mindset it enables of the types of challenges you take on. So my talk today is really going to focus first on the tools and practices and interweave teams and collaboration throughout. And I'm going to start off with the Ocean Health Index because that's where the story starts chronologically. So I mentioned that this is an effort that we have started in 2012, and we assess how healthy oceans are globally around the world. And this is a project that, since we've been repeating it annually and it's a transparent and established framework, it's being considered for the United Nations Sustainable Development Goals, which I think is a really awesome example of open science being considered at the UN level as a formal indicator. So we've been able to repeat these studies every year since 2012, but that's not the way, and even though when we first published it in 2012, we intended for this to be something that our team would be able to repeat and other people would be able to build off of and other people would be able to contribute to and we could improve along the way. When it actually came down to repeating it for the first time in 2013, this is the way we felt. We were a team of people that each had a different skill set and were sort of mashing together different tools in a way that made it really brittle. So if somebody who knew ArcGIS left the team, then that part of repeating the work was difficult. There were some things that were proprietary and maybe we lost licenses. But also it was really hard to hand off different parts of our analyses to each other. But R, for us, has really streamlined the way we work. We're able to work not only with tabular data, but also more and more with spatial data. And it's given us other channels of communication too beyond PDFs and Word documents. It's actually enabled us to share a lot more broadly online, which has been really exciting. And it was really this story that we told in that article in Nature, Ecology and Evolution. And I think what's unique about this story is not that we say that open science and data science is really important for science, because there's been a lot of awesome research and literature on that topic. I think what makes this unique is that we shared, we were vulnerable and shared the fact that we were struggling with the way that we were working, and we shared more stories about the transition that we underwent in order to improve our practices. So it was a pretty painful time as we went through it, and we did it incrementally. So this is one of the illustrations from the paper, just trying to show that through every year through time, we were able to incrementally add more reproducibility and make it easier to collaborate with ourselves and each other while taking less time each time. And in doing this, we were really able to focus on a different challenge each year. So in 2013, we all started using R rather than a mix match of Excel and R and other tools. In 2014, we introduced GitHub for collaboration. Then we really focused on streamlining our workflows with R and GitHub. And in 2016, we launched a website that we built using R so that we could easily update it and maintain it with these annual assessments, and didn't sort of removed a big part of maintaining like a larger website. If we were able to maintain it through R, that just reduced a big amount of work there. And we also then focused on efficiency, and ever since 2018, we started a mentorship or a fellowship program for graduate students where we train them up in data science and in our practices, and they're able to repeat this assessment each year, which is really awesome as an opportunity to teach them and get the assessment done with less time and resources, which is really great. So what that looks like in a little bit more detail is that reproducibility is really the keystone of how we work. So we code and we use version control, and that was a big step up for us in 2013. We're all working locally using R and RStudio, and also using a similar syntax for writing, a sort of similar approach to the language using the tidyverse. And then from there, we're able to use GitHub both to streamline collaboration and introduce this whole new component of communication for us. So we use GitHub as a way to have shared record keeping so that not everyone is having to download and version and store files and do that kind of bookkeeping, but that we're leveraging the fact that GitHub was built to do that for us around code. And then we're able to, like I said, introduce this whole new aspect of communication and sort of beyond sharing data and code and methods, which we do and which we focus on, but also blogging about this and interacting with broader communities around data science. So to dive in a little bit more, this is what the RStudio console looks like. And we're able to code in it and use it for text editing and GitHub sync all from the same window. And for me, this is a big deal because I can be a big curmudgeon about installing new software on my computer and setting up new accounts. So being able to do this all from a single piece of software is actually a big win for me. And it also then enables us to, I also like to see this type of interface where I can actually see the changes that have happened through time as I'm collaborating with myself or with other people on my team. So this is a screenshot from the GitHub interface where you can actually see what changes line by line and plot by plot in a familiar interface to what I'm used to with Microsoft Word. But beyond that, I think that one of the sort of unpraised things that GitHub is really great for is for discussion and project management. And this is a huge way that we use GitHub. We actually take a single repository and don't really use it for code and files, but we use it for issues, which is a way that we're able to have to-do lists and conversations about our data and methods, and it replaces email for us. So this is a big deal when we're introducing new people onto our team and offboarding them as well, is that we're not having to dig through emails and forward them to people and maybe have attachments or not, but we're able to add them to this repository, and then they have an archive of all the conversations and decision-making that went into making the code the way it is and the program the way it is. So that's one way that we use GitHub for project management and discussion and institutional memory. And it's also been really powerful for publishing. So these are a couple examples here with not only using the github.com interface that is essentially a web platform for your work, but also taking a step further and building simple websites and training books and getting our documentation and work out there. So that's a lot of the tools and the practices that we use, and that's actually was the main focus of our Nature, Ecology, and Evolution paper. But this teamwork aspect was a really critical part of why we've been successful. And we've actually been a pretty small team that has evolved, had people come and go each time. And so we've developed sort of onboarding protocols and offboarding protocols for folks. And I think that's really analogous to science research groups, where we also have folks coming in and out all the time of labs, and to sort of establish practices for what happens when you join a lab. Are you on your own to figure out which coding language you might have to use, or do we have a suggestion of the way that our lab is working? So a lot of the reason why we were able to work as a team was because we came together around a data science mindset. And this figure has been really instrumental in the way we work and the way I think about science and data. So in this image, and you can see there's this gray area in the understand, where it says understand. I feel like that's kind of the scientific question part of data science. But no matter what your research question and what your discipline, you're going to need to import your data into some kind of analytical software. And then if you take the time to tidy it before you get into asking your scientific questions, you're going to be able to leverage a whole suite of tools and practices that are built to accommodate tidy data. And the idea here is that you're not having to re-engineer every analysis you ever do to accommodate whatever form the data are in. But if you can get your data into a common format and then start asking your science questions without having to engineer your own approaches, it's actually a really powerful way to work. So in R, there's a whole suite of R packages that accompany this conceptual model, where whether you're importing from a CSV file, an Excel file, a database, if you're scraping from a PDF or another API, there's tools available at every step of the way. And these are just a handful of the tools that have been created in the tidyverse. But because R is an open language and there's all these incredible communities around R that are creating packages, there's a lot of other tools that are available that are domain specific or not that can accompany this workflow. And it really, it's really powerful for changing the amount of time you spend wrangling your data versus asking your science question. And I think that that's a big point of why we've been successful as a team in the Ocean Health Index. Another idea that made us successful was having a more open mindset. And so I have a couple definitions of open mindsets. This one is that open science is the concept of transparency at all stages of the research process, coupled with free and open access to data, code, and papers. So to me, this is the idea that open science is a whole spectrum in which you can participate, and it is not a common misconception that I hear that is publishing openly at the end or sharing your data at the end. This is part of an entire workflow that you can be a part of and collaborate in order to collaborate and share with other people. And then when you're ready to publish your things at the end, it's a click of a button rather than a huge effort to tidy up your data and get it to a point that you'd be willing to share. So an open mindset in this definition is great, and I think this is also really important to complement with the idea of collaboration, empowerment, inclusivity, trust, and safe places where you can be imperfect and share things and improve them and get feedback. And I feel like that's something that science is really all about. But it's creating this mindset where that's okay, and you have a team around you that can help support you in that effort. So some of the more concrete traits about the Ocean Health Index team that I think has helped us in this transition are that in 2013, when we first made the switch into R, we had strong horizontal leadership, strong vertical leadership, and a team mindset. And so in horizontal leadership, I mean that there was somebody on the team that was really jazzed about open science and data science and was willing to teach us or put the time into teaching us and skill sharing. And vertical leadership was so important. Our PI, it did not code. That's not his expertise, but he saw value in it, and he gave us time and space to learn and skill share with each other. And there wasn't this expectation that he needed to become an expert first in order to enable us. He trusted us to skill share and teach ourselves and to design a whole new workflow around R and GitHub that would become really powerful and make us a more resilient team than what we'd been before. And another thing is that we already kind of, even though we didn't have we were working on different pieces of the project, we had a team mindset. So we trusted each other, we talked with each other socially outside of work. And that kind of established relationships that made us more willing to do something that was actually kind of scary. Like I had taken a class learning GitHub before, and I was like, well, that's something I will never use. And in fact, when on this team, when Ben had me create a real GitHub account after I deleted the first one, I had all the emails go to my spam folder. I was like, this is something that will be totally inconsequential and not useful to me at all. And now it's like a part of my extended memory. But I think like there is a lot of inertia around new tools and new systems, and so having people on the team who are willing to support you and think it through and help you when you made a terrible username and help you figure out how to change that. Like those types of things are really important in changing your behavior. Another thing to compare this to is in 2019, where now we have overlapping and complementary skill sets, and we're a more resilient team. So what I mean by overlapping and complementary, still not everyone on our team codes, and that's fine, because that's not everyone's role on our team. But everyone on our team does have a GitHub account, and we talk to each other about data through the issues. We actually meet in person once a week to talk about data. And so we all have a shared vocabulary and mindset around data, and then are able to interoperate between our roles and the software and skills. But this resilience that's enabled, rather than having a single person with all of the expertise that could be very brittle if that person leaves, this resilience has also made it really great for onboarding and offboarding people, like I said before. So how the strategies for how we upskilled and became more fluid in the software we use and the mindsets we have are through the open data science communities that are existing. So these are the most influential communities in my life, and I would say like our OpenSci helped change the whole trajectory of my life by welcoming me into the idea that coding was a social thing and that I was welcome there was a really exciting opportunity. And then having RStudio be there as not only a community, but a software interface like I showed, and a contributor to a lot of the packages that were really meeting scientists like me where we are, which was in this like data munging stage and helping develop tools that were really they were an easier entryway for me into coding than I had expected. Similarly, R-Ladies is a really powerful global network for bringing more gender diversity into the R programming language, and their leadership and visibility has been really important for me as I've gotten into R. Mozilla has been incredibly influential, particularly over the years through their Mozilla study groups and seeing the Mozilla Science Lab. And then also in the past year, as I've been a fellow and learned so much more about what it means to work open and what the bigger internet community is doing in the scheme of open. And also the Carpentries, where I was a learner of in the early days and then became an instructor, and actually some of probably the best teaching training I've ever gotten in all of my career has been through the Carpentries instructor training. So this helped us not only feel like we were a part of this whole world of coding, but it also helped us learn skills and also contribute back to skills. So we read people's tutorials and watched their webinars and then turned around and gave webinars of our own and tutorials of our own. So it was really fun to build this community locally as well. So that's what we've done as a strategy to skill share locally, is to not only have these data-centric chats within our immediate team, which we call Seaside Chats, but also create local communities. So we created a Mozilla study group called Eco Data Science. We created a local chapter of Our Ladies, and then we also started this fellows program. And all of these were focused on taking what we'd learned and help remixing it for our audiences and building from that. So this is really what I envision as being the way we work and the way it would be awesome if environmental science worked, where we've got all of the data that we collect based on the questions we have and the expertise we have, and that we are able to communicate that to our stakeholders and to get actionable science to policy and action and change by leveraging this whole world of data science and open communities that really streamline what we're good at with the data part. But I feel like right now, it really looks like this, because we're pretty much on our own to learn these skills and to sort of discover this as both as individuals and as teams. So that's, this is this piece I feel like that's missing in the middle of that are both the tools, the practices, and the teamwork. And if you're outside of this loop, if you don't feel like you're on a team and you don't know what's possible and have these tools and practices, it can be a really lonely place. And so I've been trying to think, based on my experience with the Ocean Health Index, I've been trying to think of what are other entryways into welcoming people into this feedback loop. And that's what I've been doing with Openscapes. So we're back to Openscapes, which is a mentorship program where we welcome scientists to open data science by mentoring them as teams. So we're trying to engage scientists more broadly by building awareness and excitement through empathy, through art, and through storytelling, and then empowering scientists by connecting them with existing communities and existing tools that meet their needs and that sort of understand where they are and help them go from there. And also then to amplify the fact that open data science is important, and to both amplify scientists that engage in open scientists and help them figure out how to amplify open science within their own communities as well. So the inaugural cohort in 2019 was a really exciting group of people. We would meet twice a month all together on a Zoom call. So it was a remote program, and we had teams participate together. So in this first cohort, we had 7 labs where both the leads and the members of each lab participated on each call. So this was about 25 people on each call. And the reasoning behind that is the point is for everyone, no matter the career stage, to see and value what's possible with open data science. And then it's important for leads to value it and enable their members to invest time in learning and establishing these skill sets and systems for the research group or lab. And the members of the lab have guidance on what's possible, they have agency, and they have support from their PI that provide time and potential opportunities for conferences and meetup groups and support more generally. And the idea then is that everyone champions open data science and grows this community practice no matter what their role is. And this is really modeled after what we found with the Ocean Health Index and what we found made a resilient team. And so some of the momentum we've had through this first cohort is we've had a quote from Malin Pinsky at Rutgers where he was like, "This isn't just about coding in GitHub. This is about changing the way we do science." And I was like, yes, that's what I feel. And so to hear you say that in a few months is so exciting. And then this is a screenshot from 2 UW folks, Chelsea Wood on the left there is faculty at the School of Fisheries and Aquatic Sciences, and Holly Froelich was a graduate there. They both participated as two of the champion leads in the first cohort, and they didn't know each other, but now through having this similar skill set and experience, they've realized also that they've got similar scientific interests and are having a new scientific collaboration based on this experience, which I think is awesome and plays into that feedback loop in general. It's also been really cool on like a programmatic sense, kind of the momentum we've had, because I intend to lead more cohorts through time. And so this is Mozilla during my fellowship, one of the, in a list of all the awesome things that go into being a Mozilla fellow, having the global voice of Mozilla to amplify your work is a big deal. And so alongside all the work Mozilla is doing on fighting misinformation and thinking about healthy AI and global privacy and security, they're also talking about open science, which I think is so awesome. And so it was really exciting to have Openscapes have that kind of visibility. But so what can you all do? How can you feel empowered and excited about open data science, no matter where you're starting from and what sort of constraints you have? So the main thing that we came up with throughout the whole Openscapes program so far is to talk about your data. Like, that's the first thing you can do. This is a paper that Ben mentioned that we just published. It's co-authored with the 7 Openscapes champion leads, and it's about transforming the way you think about science by talking about it. And we give a 10-week list of suggested things to read and do and talk about, and then but the point is to really make it a habit and a norm that as a team you can start to think and talk about data together. And I'm really focused on science teams that already exist, like a research laboratory, how there's already people together that are having similar interests, probably collaborate quite a bit on the science part, and how can we also streamline the way they collaborate and think about data together. So while you're talking about data and going through those 10 weeks, another thing to start doing is to have this team mindset. And what I mean by that is to redefine what it means to be a collaborator. Who are your collaborators? I hear a lot that scientists think that they don't have collaborators or that they work alone. And so we want to redefine collaborators to include the research team, the folks that are around you, but also the idea that you in the future is your most important collaborator. And so anything you do today should be helping you next month be able to pick up on where you left off, or you next year. And to also think about the idea of future us. Like, what would make it easier for all of us, whether that's our research group, or whether that's the student I might have one day when I become a PI, or whether that's a postdoc that's going to join our lab. Like, how can you reimagine who future us is? And maybe future us are the scientists that are upcoming, and so it's important to design a new university course to upskill future us in that bigger sense, or include people beyond your domain. And that gets into redefining community. I never thought that the internet was a place for community, but I found that through Twitter, which I'll mention more in a moment. But by connecting with people through Twitter and to really feel welcome in communities beyond my own domain and beyond my own physical location and beyond my own university has been really important. And then it's also been neat to see how redefined communities on the internet also lead to redefined communities on the ground, for example, through Our Ladies or through coding clubs that also introduce you to people beyond your domain. And then this other idea is to reimagine challenges. Separating your science from your data is something that was really hard for me as a PhD student. I basically thought that renaming columns in a data spreadsheet was tied to squid ecology. So I was asking squid ecologists. See, I'm still very scarred by all this. But I didn't know how to ask. I didn't have vocabulary to ask it. And so separating your science from your data is a big part of this mindset. And that goes along with expecting that there's a better way to do something and that the default is not for you to engineer something from scratch. So if you're copying and pasting something 10 times, maybe there's a better way to do that. If you're writing the same thing over and over or getting into some intricate regular expression, trying to parse out text, like there's probably a way to do that. And just having that expectation that this is not tied to your science and to your squid migration research questions, but actually is part of the way data scientists think or other ecologists think. And then a big part of this too is having confidence and agency and community to like not feeling like you're alone and not feeling like it's too late for you. I have conversations with folks all the time that are like, I never learned this. I don't know how that was possible, but everybody else figured it out. And you're like, no, we never learned this. Like, this is a bigger problem. It's not, you're not alone. It's not too late. So another thing is to enable and support leaderful teams. And leaderful is a word I just learned at MozFest this year, which is an awesome festival by Mozilla. But the idea of thinking about horizontal and vertical leadership, like how can you be a leader in whatever situation you're in and enable other people? So I think of learning what's possible and how you can teach and lead based on the communities that I think supported me. And obviously these are our focus. There's a lot of other communities in Python and other great groups as well. We can talk about those too. But also creating skill sharing spaces for yourself. So how can you normalize data discussions in your own lab? In Openscapes, we had the homework for Openscapes was that everybody had to have a data-centric chat every week, and we had ideas for them. And so they owned it, and they named these things based on their locations. We had Bluffside chats, we have Bayside chats here at UW and Chelsea Woods Lab. But also finding coding clubs, finding hacky hours, starting them yourselves, looking at university courses. I should have talked to your data librarian on this because this is a huge part of how knowledge is spread at universities and who to go to learn specific things about your universities. But a lot of this is about, thinking about how it's impossible for anyone to be able to do this all by themselves. Who can you look for help? Who can you form alliances with? How can you have these overlapping skill sets and build this resilience and this trust on whatever teams you're on? And I think that a lot of that comes with leadership, and it's also like kindness plays a role. And I think, I am a happier scientist based on these open communities and practices. And I think that it's a cool way to ignite that kind of change in science more broadly. I mentioned Twitter. Twitter has been hugely influential on my career and on my life. It's why I'm here today. It's why I was a Mozilla Fellow. And I thought that I thought that Twitter was a megaphone for angry people. That's all I knew about it, but you can use it really selectively and deliberately for science. I joined Twitter to learn R specifically, and that meant that I looked at this hashtag rstats and I followed people like this top line of R leaders, and I just listened, and I started following the people that were following them and seeing what they were talking about and kind of looking at the resources they were pointing to. And at some point got the courage to like something or to retweet something or to amplify someone. And so I think that it's a really great strategy. And then you can start bringing in other complementary things in your domain. So this next line are sort of environmental open data science accounts, if that's interesting to you. And on this bottom line are the initial Openscapes champions, who are folks that went from not being interested in open data science to being champions for it in a short period of time, but are also doing awesome science that should be amplified. So all of these things, I think, are some examples of what you can do to upskill yourself and to build communities. But if you want to get involved in Openscapes or more broadly in open data science, there's some options here on our Openscapes website. And like I say, I do plan to lead more cohorts and to really just increase this visibility and the value of open data science moving forward, because I think that this can be our reality. It doesn't have to be in the future, and we can all get there if we if we start talking about it more and supporting each other. So thanks all so much. Thank you all so much. I do have both Ocean Health Index and Openscapes stickers if you're interested. And all of my slides are available online through GitHub or Openscapes website. So thank you very much.
Great, thanks a lot. That was fantastic, and really confirm my impression that Julia is one of the leading visionaries of open science in the present moment. So would you like some questions?
Yes, I'd love some
so
questions.
We have some time for questions.
Yeah, please. The type of what? Yes. Yeah. So when I studied squid as a PhD student, yeah. So that project, I was actually attaching archival electronic tags onto live squid. So it was a tag about this big. The squid are about as big as I am. And I'd put these on these squid and release them back live into the ocean, and they would swim freely and collect data at every single second while they swam. It was so cool. And so these squid would actually swim like a half a kilometer deep every single day, and then some days they'd swim 1.5 kilometers deep, through incredible pressure, low temperatures, low oxygen. And it was so cool, and I was able to learn where they swam. But part of this was that, and then I was able to connect that with remote sensed data and try to map out where they had been geographically as well. But yeah, I mean, part of the demoralizing part is after all of that, experimental design and learning about squid ecology and oceanography and fisheries and all of these things within my domain, I then went out and did all this field work. It's at night, you're catching these big squid with these big hooks, and it's dark, and you're it's chaotic. And then you drop them back in the ocean, you never know if you're gonna see it again, and then you get this GIS beacon that says that the squid has the tag has popped off the squid, is now floating at the surface and uploading data, and you can go find it and get high resolution data. So I do all of that, go out on the boat, get it, and I'd be physically holding this data in my hand that had traveled with this squid, and it was too big for Excel. And I could not open it in Excel, and that's the only thing I knew. And so then it was this chaos of learning MATLAB by myself. And I learned MATLAB because that was the first thing that someone suggested to me. It wasn't because I was like, oh, should it be open or closed? Is this a good tool for this problem or whatever? So that was a longer answer, but it was pretty cool data and work for sure.
Do you believe RStudio are you firm believer that it's good for all sciences, or do you think there's certain sciences that maybe it's better for than others? And I really asked this question as a third-year PhD student. I came in and was told to learn MATLAB in my lab, and then my psych department taught me RStudio. Now I've got other people in my lab trying to now put Python on me, and I'm a little bewildered and don't know where to go. And we do neuroscience and the physiological stuff, and I'm just I don't know where I should actually focus all of my attention at this point and where I'm at.
Yeah, so that's a good question. It's a common question. I think the best language is the one that your community is using. So talk to other neuroscientists and figure out what they're using, and I think that's the one to invest in now. I think what is cool about a lot of these languages are that I think of them kind of like Italian and Spanish. You know, they have similar roots and structures, and you can once you have the ability to learn one language, you can translate a bit if you need to. But I think that what your community is using is the most important thing. So, but also, I think incremental change is also really important. Don't go and throw out MATLAB all today and then start from scratch with Python. How can you sort of wean yourself off or transition in a way that still lets you do make the progress you need? Because if it's too big of a task, you're just never going to do it. If you have to completely change something, but it's hard for sure. Yeah.
I noticed that you had several pie charts when you were trying to graph your team's kind of transition and the gains from that, where you Curious about that.
Mm-hmm.
And the slightly bigger question that I have, and with a little more full focus, is around this, I guess, in my own mental model, there's kind of this a gap between scientists moving towards much larger volumes of data, where they're using more sensors, more technologies that are actually just collecting discrete data that can be analyzed, outside of just needing statistics. Like there's a lot more shading
Mm-hmm.
to full pipelines and processes, which might be more out of HCI or in industrial areas, where you're like the actual building models and analysis components are actually a smaller part of a much larger development process, which is now also like, you know, in robotics, obviously that's like a large part of it. And I'm in dramatics, so there's this component there. The actual study includes that human component of the whole information system. So there's kind of a preference for Python there. Because, pipeline? Sorry. Anyway, so where do you get, like, where do you see a link in this? Or is it very field specific now that you work with a lot of more training communities? Do you see there more conversation around this and kind of in there? How do you say what is data science and what is not, and what is really where we're going as researchers and developers? Because my line dissolving between those two.
Yeah. No, I think, yeah, it's hard to have a definition and stick to it for sure, because there are so many lines and in our places that they overlap. In that one figure with those pie charts, which is just a illustration, we don't have data